Hello and welcome back to Math 8. This is a video over section 4, and we're going to be talking about the introduction to functions. So we're going to be able to identify functions from tables, graphs, and equations, and we're going to determine if a real-world situation describes a functional relationship. So while we identify functions, okay, it's important that we understand the definition of a function. So a function is a relation in which one input is paired with exactly one output. So that's a little bit much to stomach. So let's say this. I'm going to zoom in over here, and I'm going to say this. A function, okay, for every x value, there is exactly one y value. Okay, and so what I often do, and that's what, and this means the same thing here. When you say input, okay, that's your x value. Okay. And your output is your y value, all right? So when I do this, one of the things I think of, something that you use all the time is a computer. So I want you to think of a computer, okay? A computer is just one big function, okay? In a computer, when you press a button on the computer, okay, that's like your x value, okay? The result on the screen is your y value, okay? So what I often think of is, just like using like a remote control. If I turn the TV on, if I hit the power button, only one thing happens, okay? So if I press the power button, only one thing happens, all right? The TV turns on, okay? If you think of like a Word document, okay? When you press the K button, okay, in a Word doc, that's your X value, a K pops up on the screen, okay? Nothing else happens, all right, when you do these things. Otherwise, it wouldn't be functioning properly. So think about your phone, all right? If you hit the home button on your phone and it unlocks the phone, and you use like your your thumb for your to unlock your phone, all it does is unlock your phone and it allows you to pick an app to choose from. Okay, imagine if you unlocked your phone and all of a sudden it opened up your text messages. It also called your mother, and it started playing a bunch of music. Okay, when you do something on your phone, it only you press a button, only one thing happens. Okay, so your phones are essentially just just functions. Okay, in all your computers. Okay, anything that computes. All right, so let's talk about identifying functions. Okay, so let's think about this. All right, so what we had is that definition where every x value is paired with exactly one y value, okay? And the one thing we have to look at is, the x values don't repeat, okay? They're all unique, okay? So -3, -1, 3, and 5, these are all different numbers, okay? And that is, tells me that we have a function here, okay? And each of these values are paired with exactly one y value, okay? Now the y values can repeat, all right? Notice how you have 6 and 6. So your y values, and your y values can repeat, okay? But your x values can't, okay? And so just looking at this set table here tells me that yes, this is a function, Okay, this is a function. Okay, now if I go over here to this side, notice something here. Notice that my x values repeat. Okay, these values repeat and they map to other y values. Okay, so since my x values repeat, all right, this is not a function. Okay, so your y values can repeat, but your x values cannot. Okay, all right, so then that it's like, think of it like this. Like if you press the 9 button on the computer, all right, you're getting two different things that are popping up. All right, and that's not what we want. Okay, so one of the things that we can do is look at that. All right, and determine, do we have a function or not a function? Okay, so let's look at each of these. And so what I notice is that my x values here repeat. Okay, -3 repeats, 4 repeats. So x values repeat. Therefore, this is not a function. Okay. All right, over here, same thing. My x values repeat. This is not a function. Okay. Now over here, all my x values are unique, okay, given this table. So looking at this, all right, all my x values are unique, so x values, we can say, don't repeat. All right, so then we have a function. So this is a function. All right, and that's that. All right, so what we can look at are different equations. Okay, so I want you to notice something here. All right, so in this table, all right, we have functions versus non-functions. So I have the ability to look at functions or look at equations and automatically tell if they are functions or not. Okay, and there's a difference between all of these functions and these that are non-functions. Okay, and the difference is this. Okay, I have a y, my y values are raised to the first power, okay, where my exponent is 1. All right, so in all of these, I have just y equals, okay, or just a single y value, okay. So I just have y to the first power, which is just equal to y, all right. This is what I'm looking for, all right, when I'm looking for functions. Now, if I don't have a function, notice what we have here. Notice that we have y squared and y squared, okay, or no y, okay? And that is an indication that we don't have functions. Now let's take a look up here. All right, notice that y squared exists in each of these first examples where they are not functions. Okay, so I'm looking for something that's like y to the first power or y equals something. That's going to tell me that I have a function. Okay, now the next one we're going to talk about is the vertical line test. The vertical line test allows us to look at a graph and determine whether or not it is a function. All right, and so what I want to do, let's go ahead and plot these points on this graph. So I've got -3, -4, okay, that point. I've got the point -1, 0, and then I've got the point 1, 4, okay? And so I have this line here. All right, and the vertical line, and this is a function, okay? This is actually the equation y equals 2x plus 2, okay? We'll talk later about how I'm able to just automatically know how to write that equation. But just trust me for now. But what I notice, okay, first of all, is that y is just raised to the first power, okay, equal to something else. That's an indication that I have a function. All right. The other thing is this thing called the vertical line test. And what that says is that if any vertical line passes through no more than one point, then the relation is a function. So let me pop up a vertical line here so that I can move it around. Okay, so here's this vertical line. Now what I'm going to do is I'm going to move this line across the graph. And what I want you to notice is that my vertical line only intersects this line once at any point along this graph, okay? So because this vertical line only crosses my graph once, okay, and so at any point, here's my intersection point, okay? If I move it over here, here's my intersection point. It's only intersecting this once, okay? Therefore, if I use my vertical line test, and what I normally do is just use my pencil and move it across the graph and ask myself the question, is this vertical line only hitting the graph once? If that's the case, then you have a function. All right, so let's take a look at more of that on the next page. Okay, so on this page, we have examples of graphs that are functions and examples of graphs that are not functions. Okay, and so let's do the vertical line test on these. All right, so if I take a look at this first graph, okay, this V-shaped graph, what I have is as I go from left to right, my green line is only hitting my orange line at exactly 1 point. Okay, so as I move that across, it's only hitting my graph at 1 point. Therefore, it is a function. Same thing over here with this one. All right, this one looks a little bit funkier, but as I move across, it's only hitting this graph at 1 point. Okay, it's not going to hit it at any other point. Okay, it's just 1 point. All right, now if I look over here, and right here I'm hitting it at 1 point, but all of a sudden, boom, I'm hitting this graph at 2 different points. That's why we don't have a function. Okay, and I can continue to move this along. Oops. All right, continue to move this thing along, and it's going to hit this graph here and here. Okay, if I move it along even further, it's still going to hit this graph at 2 different points. All right, therefore it's not a function. Now the other example is a vertical line. All right, a vertical line, all of a sudden, boom, I got all these different intersection points. Okay, and so for one x value, I have all these different y values. Therefore, it's not a function. Okay. All right, let's talk about something else, determining functions from a scenario. So is the height of a football kicked across a field a function of time? Okay, so let's think about what happens as you kick a football. All right, and I used to be the punter on the 5th and 6th grade football team. There is a story that I have where we had a fake punt. And I threw an interception, and they ran it back for a touchdown. And that was kind of the moment when I realized maybe punting in football isn't for me. But although I still punt the ball, as the football as much as I can. Okay, so let's talk about what happens. All right, at time 0, when you first initially punt the ball, the height is at 0. Okay, and let's say that you punt the football for it's airborne for 3 seconds, okay? And let's say that you kick it at a maximum height of 50 feet, okay? So let's say that happens at 1.5 seconds. So as this time goes on, all right, what you end up getting here is you get this, what happens is you kick the ball, it goes up in height, it hits a maximum height, and then the football comes down again, and then it hits the ground, okay? And that's it. It might bounce again, but that's the idea. So think about it. All I'm doing here is, thinking about this situation. I can draw a vertical line and realize that, hey, this vertical line is only going to intersect that graph at 1 point. Each individual x value matches up with only one individual y value, okay? And so that, therefore, yes, this is a function. So yes, this is a function. Okay? All right, the next one said, let's look at this example. It says, a survey asked high school math students their ages and heights. The results are shown in the table. Is the height a function of the age? Okay, so x is our age. Okay, so this is my x value. the height is my y value, okay? And I'm telling that just pretty much because not only from the table, but looking at the graph, okay? And what I notice here is that in this situation, this is not a function, okay? Because we are taking a look at students that are different ages, okay? And the other thing that I know is that, you can have a sophomore in high school, okay, someone that's 16, that's like really tall, that's like 5'7", okay? Which is the same thing as 67 inches, okay? So, it's not uncommon to have a tall person that's young, okay? So age, or height is not a function of age, okay? And that's because my x values repeat, okay? And you can also, draw a vertical line and do it that way, all right? It doesn't really matter. But as long as we understand, yeah, you can tell me if that's a function or not a function, okay? We got 1 point here, but here we got 2 points, okay? And that's not what we're exactly looking for, okay? So this is, hold on, drop my pen. This is not a function. Okay. All right, so that's all I got for this video. Let's get started on the notes quiz, and let's do the Edgenuity assignment, and we'll see you soon. Thanks a lot. Bye.